Well, welcome everybody to this webinar. This is Emerging Jobs, a Future with Intelligent Robots, presented by Monash Tech Talks. My name is Malone. I'll be your host for this virtual event. I have a background as a professional athlete. I've worked in an AI startup that used natural language processing and autonomous animation. I've invested in a bunch of startups that are using various AI techniques within their development stack. And like everyone in society, in the developed world, am touched by AI in day-to-day life. But I'd like to begin by respectfully asking everyone who's participating in this event to make a mental acknowledgement of the Wurundjeri and Bunurong peoples of the Kulin Nation, the traditional owners and custodians on the land, which I and many of you will be meeting from tonight, and pay respects to their elders, past, present, and emerging. I would also like to acknowledge the traditional custodians of the various lands on which you are all located today, and the Aboriginal and Torres Strait Islander people who are participating in this event. It's now my great pleasure to introduce our wonderful panelists. We have, and I'll ask them to throw up a hand and give us a wave when I introduce them. We have Associate Professor Aldeida Aleti, who's also the Associate Dean of Engagement and Impact. She is the Associate Professor at the Faculty of IT at Monash University, and her research is in the intersection of artificial intelligence and software engineering. We also have joining us Professor Dinh Phung, Director of Research from the Department of Data Science and Artificial Intelligence. Professor Phung obtained his PhD from Curtin University in 2005 in machine learning and multimedia computing. His primary research interests include theoretical and applied machine learning, a focus on deep learning, robust and adversarial machine learning, optimal transport and point process theory for machine learning, generative AI, Bayesian non-parametrics, and graphical models. We also have Dr. Aleti, who's the lead in robotics and medicine and at the Interaction Laboratory. She is also the director, she is the director in that laboratory. She is a roboticist interested in human-robot interaction, automation, and haptics with applications in medicine, construction, and service. And finally, joining us from the United States in Palo Alto is Dr. Jay Chakravarti. Throw us a wave, Jay, who's a technical expert in machine learning and robotics, who works at Ford. So Jay is super interesting. He's responsible for leading a group at Ford Motor Company that's focused on the perception mapping and localization for autonomous vehicle research. So this involves developing the machine learning algorithms that enable autonomous vehicles to use cameras and LiDAR to detect, track, and predict the intention of other agents. Other agents can be cats, dogs, human beings, other autonomous vehicles around it in their environment. So Jay has filed over 30 patents, and his primary research focuses is related to developing techniques for self-supervising these ML algorithms, which otherwise require a lot of manually labeled data. So there's a lot of technical words in those introductions, and we're going to get into all of that immediately. And as we do so, I'd like to set the scene. So I'll hand over to our panelists, and what we'll do is set the stage of where artificial intelligence is at in today's world. And I'll go to you, Aldeida, first. And if you could give us a snapshot of where AI is being applied, either in relation to your research, where you're seeing it's being applied in the industries that you focus on, that would be fantastic.
Thanks, Liam, and hi, everyone. I'm very excited to be part of this panel. In terms of where AI has been applied, we can see AI being applied in almost every area of our lives. We can see AI in healthcare for diagnosing diseases. We can see AI in self-driving cars, AI in stock trading, robot control, law, scientific discovery, video games. And in my area, we use AI to write code, to test code, to repair code. So it's not completely automated yet, semi-automated, so human in the loop, but AI basically can write itself. So there are many other applications of AI that are so embedded in our lives that we don't even notice. I mean, everybody uses Google Maps. to find how to get to your friend's place, for instance. And there are optimization algorithms in the background that try to find the best way to get there. And we don't think of optimization as AI. We often think of AI as machine learning, but optimization is also a subfield of AI. And it's about searching possible solutions to a problem and identifying the optimal one. So we've done a lot with AI, but we still have a lot of way to go, because AI is not very good at particular tasks, in particular when it comes to context and intention and metaphors and nuances and so on. So, and probably we'll talk about this more in this panel. So I'll leave it there. Thank you.
Dinh, I'm going to jump to you now. You're very much focused, I think, on the intelligence stack when it comes to machine learning. Perhaps just talk to us a little bit about how you see that from an academic perspective being applied in the real world, and maybe some gaps that you think there is around AI at present.
Okay, so thanks, Liam, and hi, everyone. I think Aldeida has captured pretty good pictures of applications of AI. And I think I don't have to say much, right? It's a very well-known, and everyone heard about this. The buzzwords is around. So from my perspective, what I would like to add is perhaps the fact that what is the AI means, right? So when it comes to AI, then it also means we need to think about what intelligence is. Unfortunately, it's still a very debatable term. But I think what I can comment on is that how can we think about intelligence in relations to the technical side? Then I would say that usually it needs to have those three elements, right? It needs to be able to acquire the knowledge or keep the knowledge for the reputations. It would be able to reason, like generalize from what it sees, and abilities to learn also, right? And then we talk about, when I say about this thing, keep in mind that this is what we call cognitive intelligence. So when we talk about AI, people will immediately think about cognitive intelligence, but there's also other kinds of intelligence as well. For example, if you look at those amazing robots that Boston Dynamics has produced, they're actually called athletics intelligence. So think like, fine motor skill that we as humans take for granted. Right? We stand up, we sit down effortlessly and very easy to do, but for the machine that is extremely difficult, right? So that is another kind of intelligence that usually the community doesn't pay attention to or might not be aware of, right? So for me, what is the gap in the AI at the moment is, as a person who's been researching in this area for the past 15, 20 years, there are certainly a big progress, if I might say exponential progress in the way that it's been there. But there's still a big gap and, a long road ahead for us. I would say that three things that, for example, right now, that in my mind, that would be the current AI is not so good at. This number one is about abstract thinking. Humans are extremely good at abstract thinking. We are not there yet. The second problem is causality. Okay, causality is to deduce about what caused what. So let's say if you have a video and you see an apple drop, right? We start to speculate, and we can start to generalize to the gravity law. And if you hold another cup, if you drop a cup, it's also a drop, right? But if the machine would be extremely difficult to infer these kinds of causalities. And the third one I just mentioned is those things as related to intuitions and things that we take very easy to comprehend and perform. For example, in autonomous driving, for example, in race area, if we drive and we look at the pedestrian and just look at the gait, the way that they look, we can immediately infer that whether or not they want to stay on the road or they going to cross the road, right? But for a machine, that is extremely difficult, right? So lastly, I just want to put a thought-provoking view as well, is that instead of thinking about intelligence, another way to view AI or intelligence is examining what is not intelligence, right? So this thing that is not intelligent is very obvious, and this thing that we should avoid.
Fantastic, Dinh. And I think you touched on a few different topics there. And I think there's the saying that it's, one of the hardest things to find is asking the right question and how to actually measure intelligence across agents, whether they're biological or synthetic. And so you also touched on there thinking about intelligence, I guess, in the physical world, in the world of atoms, as opposed to the world of bits. And Ella, I know a lot of your research is focused around robotics and medicine. So maybe you could touch on and elaborate how you sort of see that being applied in the real world today.
Thank you very much for having me on this fantastic panel. I think that Aldi and Dinh have already mentioned some of the very important points. So with AI, things such as speech recognition or object classification or identifying natural human language are the things that they're seemingly far away from us, but now we are already there and have achieved them. Now, although we are already there, there are still a lot of things that can be done. And if I want to talk about my specialty, which is in medical robotics, we need to use AI to be able to inform the tasks that the robots do in different medical robot applications, for example, in surgical robotics. And the topic that I would like to focus on is medical imaging and how we can use artificial intelligence to detect certain features in medical imaging. So to give you a bit of background about this, it started by some basic approaches in machine learning, which is a part of AI. And in those basic approaches, we would have some experts in the field who would handcraft the features that we need to identify in those medical images. And then we needed to have a large repository of these handcrafted features, which might take like years to compile, maybe like 10 years, and then use that to identify those features in the subsequent images. You can imagine that this is very time-consuming and a difficult task to do. Now, the recent approach is to use deep learning. Deep learning is a subclass of machine learning. And basically, it is a complex layer of artificial neurons that can be used to identify features automatically. So instead of having the experts doing it for you, you will have the machine which automatically can extract features. And it's a useful approach because you can identify the features much faster. And this is what we work in identifying the features in medicine. And so what I want to reach here is that this is something that we're doing now, but we are still not completely good at it. It means that there are still a lot of different domains in medical imaging that we need to be working on. And one thing that I want to touch on is also that aspect of human in the loop. So some people might be afraid that, oh, if the machine is going to do everything, what will be the role of the human? I would like to assure everyone that we are still far away from eliminating human from a lot of tasks that we are doing. In medicine, we obviously and we certainly need the feedback of experts yet, but the idea is for the machine to be like an additional tool, a verification tool to be used in the domain.
Yeah, that's absolutely fantastic. And I think there's also the ethical questions that inevitably get raised. I believe there was a recent study that came out that I think an Institute of Machine Learning in Australia participated in that found that a deep learning algorithm was able to identify self-reported race from X-rays. I wasn't sure if you were across that, but I think, and as we go through this webinar, we'll discuss how deep learning algorithms from time to time surprise researchers with either novel solutions or novel biases or novel outcomes that researchers can't quite pinpoint where it's making that decision. But Jay, if we could just switch to you now and talk about how AI is being applied into, I guess, what a lot of people listening will really have a good understanding, or at least will have heard of, which is autonomous vehicles. So if you could touch on that, that would be awesome.
Yeah, so I don't know how old the audience is, but my introduction to AI and robotics was through film and cinema. You know, films like Terminator, where you had this all-conquering cyborg, or even Short Circuit before that, where you had a robot get into a car and start driving it. So that sort of intelligence, where you have this human-like or even superhuman intelligence that's embodied in a human-like bionic form and goes about doing things that humans would do, or even surpassing things like that humans would do, is called artificial general intelligence, AGI. So that's something that is sort of duplicating the sort of smarts that humans have, and we are very, 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 very far away from achieving that. What sort of all the machine learning techniques and being talked about now is getting good at doing is solving very narrow and specific tasks. So in my specific field, that is the task of self-driving. How do you train the machine to drive the vehicle? So what this entails is a lot of machine learning, specifically something called deep learning that Aleti touched on. The word deep refers to the fact that these techniques mainly use neural networks, and there are lots and lots of layers of neural networks. It's a deep sort of stack of layers of neural networks. That's why it's called deep networks, and lots of training data to be able to do some specific tasks. In the case of AVs or autonomous vehicles, you have a vehicle equipped with some sensors. So you have cameras, LiDARs, which are laser sensors, radar, ultrasonic, and some other sensors that are scattered around the body of the vehicle. Now the computer sitting in the boot of the car or in the cloud has to take in all that information and then decipher what is the safest path for the vehicle to follow while going from GPS location A to GPS location B, whilst also following the traffic rules, right? So the computer has to take in the data that's coming in from the cameras and the LiDARs and figure out that there is a vehicle right in front of it at this position. Therefore, it needs to avoid that. If it needs to change lanes to exit or entry a highway, it needs to be able to find out the best way to do that and send the right control commands to the wheels to be able to do that. So it's a combination of problems that we are trying to solve, one of which is perception, which is how to look at the video that's coming in from the cameras and LiDAR and figure out where other objects are in the scene. The other one is mapping and localization, how to find out where you are in the world. Google Maps gives you a rough idea, but you might need more accuracy than that. And finally, you need to do trajectory and path planning, which is how do you plan your path, a safe path, given this data that you're getting. And then you have a control problem, which is given the trajectory that you want to follow, how do you steer the steering wheel and increase, accelerate or decelerate to stay on the path. So those are roughly the problems that an AV is trying to solve, and it requires lots and lots of data to be able to do this.
Yeah, and it's quite possible that autonomous vehicles are probably the hardest challenge that is being solved at the forefront of commercial industry at present, and that's because you have an agent that's operating in the world of bits, the world of atoms, as opposed to the world of bits, right? And that increases complexity massively, because now you're dealing with all of these other agents like human beings and dogs on streets and other autonomous vehicles. So when it comes to building out that intelligence stack for autonomous vehicles, how much of that, what is the ratio between sort of supervised learning and self-supervised learning in the algorithms, where the computer that's controlling these cars is discovering concepts like other agents versus your team labeling that data? Because I'm imagining there's a balance between the two, right?
There's a balance between the two, and there's the most simplest way is to do supervised learning, which is to tell the neural network that these are the objects in the image. Let's say you're trying to decipher what objects are there in a video stream and what they are. So this is a car, this is a cat, this is a person, this is background. And you give the neural network lots and lots of these examples, and the neural network then is able to do the same on new input data. And not only do you have to draw 2D bounding boxes around these things, but also determine their position in 3D relative to the vehicle. How far away are these objects relative to the AV? So that's supervised learning, where you give it tons and tons of data. You have an army of labelers, sometimes outsourced to third-party companies, sometimes done within the team, that goes through all this data and labels it and then trains the neural networks with that, right? So that certainly is something that you need to do as a first approach, just as a proof of concept, if only for a small amount of data. And then as you scale, you realize that you require more and more self-supervised, semi-supervised, or even unsupervised learning, where the neural network tries to figure out some of this stuff by itself. For example, there is a method called cross-modal supervision, where you try and use another modality, the two modalities being camera and LiDAR, for example. You try and use another modality, i.e. LiDAR, which is a higher resolution, not a high resolution, but it has additional information. For example, distance to the object is implicitly given, is implicitly understood in a LiDAR point cloud. But you use that to train a camera-only neural network. So a neural network is only operating on the camera image, but it has access during training to the data from the LiDAR. So that's called cross-modal supervision. So there you obviate to some extent the need for a human labeler to come in and put bounding boxes around these objects. So that's just one way in which some of the heavy-duty manual labeling is a requirement is removed.
Yeah, fantastic. And then I'm gonna switch tacks here and move back to Aldeida. When we're looking at the code, and your focus has been on building algorithms that can work on software development, whether it's writing code or doing bug reporting. When we think about the bias in code that already exists from human developers, and I think there's a great example from when YouTube was first put on iPhones, and it could only rotate, I think, to the right because it was built by male devs and they were only testing on each other, so it could only turn to the right, where you had a greater percentage of the population of women who were left-handed, but it couldn't turn to the left. Maybe talk to us on how we think about bias emerging from AI that write code. Is that something that you've looked at?
That's a good question. And bias in AI has received tremendous attention. You mentioned one example that relates to design and not necessarily to data, because we talk a lot about bias in data, and we know that, and then AI can amplify that. But there is also the issue of programmer bias. And we have examples from design in general, like you think about mobile phones as well. The size of it is quite big. And for women hands, it's quite hard to keep it with one hand and, do the swiping tasks. And that's because they haven't been tested with more diverse set of users. We're thinking more about this issue of diversity and diverse set of users with diverse needs in software engineering, mainly when it comes to requirements. So how do we solicit requirements from different users, not only a specific set of users? We can think of, for instance, age or gender of country of birth as particular set of attributes that we want to cover really well so that the products are more inclusive. Another example of design and not necessarily data, I'm not sure if you remember in 2015 where Google was found to be classifying images of people with a certain color as chimpanzees or monkeys. And that's, again, a design issue because they use this skin tone scales, which is called the Fitzpatrick skin type gradient. And that's not the only reason, but that is one of the reasons, which describes 4 white tones, 1 black tone, and 1 brown tone. And that, again, is a design issue. When it comes to code, and the issue that I've been mainly looking at, how do we use automated program repair techniques to automatically find bugs in code and fix it automatically. And that's usually done by using optimization techniques such as genetic algorithms that introduce random changes until it finds a fix. So this is for traditional bugs. Now, when it comes to biases and unfair software, how do we fix these other kinds of bugs, which are the biases in code? And that's a more difficult problem to solve. And one of the main reasons is because it's hard to define what bias is. And it depends on context, it depends on the problem, for example, because in particular, when it comes to machine learning needs to discriminate. I mean, that needs to discriminate cat photos from dog photos, needs to discriminate between different objects. But when is discrimination wrongful discrimination? For example, there was this case of an insurance company that was discriminating in a way based on gender, but based on historical data. Men were identified to be more likely to be in an accident, and then they were offering better rates to women. And is this wrongful discrimination? So who decides? So when it comes to code and writing unbiased code, we have people writing this code, and they have those biases. I think everybody is biased. I mean, we are, because we live in a biased world. So when do these biases become wrongful discrimination, and who decides? That's a very difficult question, I think, that we're still scrambling with, and we don't have a solution.
Yeah, for sure. So trying to get those biases not to transfer into algorithms is an incredible challenge. Just thinking about emerging jobs, given that that is sort of the focal point of this event, and I'll stay with you, Aldeida. When you think about the amount of capital that technology companies, all companies around the world, are allocating to people in IT or to software development or software engineering, it would seem obvious to anyone that optimizing that workforce would be an intelligent thing to do. So what gains in optimization have you seen from the techniques that you research?
Yeah.
And what's a couple of examples of that?
So I focus on automation, in particular automation when it comes to software development and software engineering. And we have some very good examples of automation. For example, we now use cloud-based services without having to think about how these different tasks will be scheduled in the cloud. And we used to do this manually. We used to specify, where a particular task needs to be executed. And now this is done by, for example, AWS automatically. So another example is continuous integration, continuous delivery. So, you just continuously upload new versions of your software that get tested automatically in the background. For example, Netflix, has the amount of changes that they upload through continuous integration is in the thousands every day. So there's quite, this is an area that has helped in developing software in a much more effective, efficient way and higher quality. But a recent development that I'm very excited about is this idea of ML Ops, which borrows from DevOps, which is about developing a pipeline for ML integration in different business processes. I have great hopes because this, I think, will make the adoption by companies, ML adoption by companies, much more easy and faster. So it's the intersection between software engineering and machine learning, which requires a specific set of skills, where we have big gaps because it requires people that understand how machine learning works, how these algorithms work, but at the same time, they have the skills for building high quality, large scale, scalable, reliable, fair, safe software system. So if anybody here is thinking about what kind of job will be very exciting in the future, this intersection, I think, is really exciting. And I can see, this gap. We have companies coming to us looking for this talent, and it's very hard to get.
Yeah, absolutely. No doubt about it. So, Dinh, I'm going to transfer over to you here. If you were thinking, if say you were a graduate of high school or you were a first year university student studying computer science, what programming languages would you be focusing in order to stay relevant in about 5 years' time? Would you be thinking Python, JavaScript? What would you be thinking about?
All right, Liam. So before I go to that question and to attempt to that answer, so I would say that first of all, I mean, the field is growing very fast, and then if not sort of like exponentially. So what I usually talk to my students and so forth is that you need to keep in mind the difference between skills and knowledge, right? Skills like programming languages, I think, can evolve very fast and change over time. So today you can have a framework on TensorFlow 1.0. Next time, next 3 or 6 months, you got TensorFlow 2.0. You go with PyTorch, you go with MXNext, and so forth. So I mean, as a general thing that I think is going to be useful for a student or graduate student to think about is to be wise about the difference between skills and knowledge. So skill is a thing that more or less gonna be demanded and change faster. Knowledge, on the other hand, change much in slower pace. So it's always a good strategy to build up your knowledge, to be solid about what you know. And then I think the interesting things about programming languages is that you know the principle, and then you can learn the new languages very fast, right? So you can learn from one language to another one. You learn Python, and then you can learn R and things like that. All right. So once again, my message is to be able to distinguish between these skills and knowledge, and have a good strategies about this. So in terms of the skill and programming languages, that the question that you ask, I mean, I would say that, for example, even though a lot of people now want to learn about Python and R, they have their great advantage, but I would always emphasize on C++, because this C++ is such a wonderful language. And I think when it comes to productions, then you still need to optimize and make it run really fast. So having a solid foundation on C++ is something that I highly recommend. I mean, relevant to deep learning, then of course, knowing really well on Python and R is absolutely recommended, because as a job of a data scientist, you need to do a lot of data cleanings and clean things up and then extract features. And if you use scikit-learn package, for example, then it can significantly reduce your effort and get you ahead of your in your jobs. In deep learning, then of course, if I might say, there's a contention between PyTorch and TensorFlow. For me, in my deep learning course, for example, so I encourage my students to look at both, but I slightly more focus on the TensorFlow. The reason is, in the TensorFlow, at least years ago, it doesn't depend on the dynamics computational graph, which means that it might be slower first, but when you deploy in practice, it's always really fast, right? And then if you take on Tensor CRT, those ones that NVIDIA has been promoted, because it can optimize on the hardware, then you can sort of like speed up like 10 times on our original cost of the TensorFlow, for example.
Yeah, great. So a lot of variety there. Jay, from your perspective within the AV industry, if you were an IT graduate or a first-year IT student, what would you be thinking about from a skill set perspective? What are you seeing from the demand from sort of an employment point of view in that arena?
Yeah, so for AVs and specifically machine learning in AVs, basically the car is a robot, and robotics existed before the demand for AV engineers. In robotics, there's something called real-time processing. So there you have to process frames or incoming data at the rate of 30 frames per second, or every frame needs to be processed at 1/30th of a second. And so the best language to do that traditionally has been C++. And as Dinh mentioned, it's a very good background for any kind of programming. So an IT person out of college needs to be at least in college needs to be at university needs to be very familiar with C++. They need to know Python, because Python is a language of choice of machine learning, as Dinh mentioned, and specifically these frameworks that enable you to program these neural networks. So you're not going to so neural network, you're not going to program it neuron by neuron and layer by layer. You're going to use these frameworks called PyTorch or TensorFlow, as Dinh mentioned, that really simplify the task of programming these networks. So I would encourage them to take machine learning courses, or even if they're not able to, just download tutorials, online tutorials in machine learning and TensorFlow and PyTorch, and start going through some of the networks that are that they can just download with some data that they can also download and start training them and then test them. So yeah, so an IT person or even anybody out of university, if they want a job in this field, they more likely than not, it needs to be a STEM graduate, so science, technology, engineering, and mathematics. They need to have solid mathematical skills. They need to know about probability. They need to learn a little bit about optimization if they want to go slightly deeper into the field. And some of these skills are available, some of these courses are available at the undergraduate level. But if you really want to get into it, you need to do a master's or a PhD. Maybe not a PhD all the time, but certainly a master's. So, so these are some quite theoretical concepts. If you really want to get into it, you need to have very good mathematical backgrounds. But as Aldeida was mentioning, there is a good sort of confluence between software engineering and machine learning and this upcoming field called MLOps. So there, maybe you don't need that much of the mathematics, but you need more of the software engineering. And what MLOps is this setting up of this data pipeline where you have the data that's coming in from the field. You label it or self-label it or self-supervised label it. You upload it to the cloud. You train your networks with this data, label data, and then you test it in the cloud and then download it onto your AVs or whatever other embodied robots you have and test it in the field. And then do this in a loop, because you're never going to be perfect the first time. And then you're going to get more and more data from the field, and you're going to keep training. And then you're going to use model in the loop to do things like auto labeling and things like that. So this is a whole new emerging field called MLOps, and like Aldeida, I'm extremely excited about that. And this is something that fresh graduates can look into pursuing.
Yeah, absolutely fantastic. And I think a key piece of the advice there was get your hands dirty early on and get into the weeds of it. I'd now like to switch and sort of focus to the future of AI. And Ella, I'm going to come to you first. I think the theme of your work has focused around the human robot, or I think we could describe it as human intelligent machine or human machine interaction. How do you think about that interaction at present and the interfaces that we use between humans and machines? And where do you think that transitions to? Do we end up in a future where we're using a BMI, like a brain-machine interface, or where does that eventually evolve to?
Yeah, that's a very good question. And to answer this question, let me first go back in time and look at what robotics has been like 20, 30 years ago, and where we have come from there. So 30 years ago, we had robots, but they were only used in structured environments, such as in car factories, for example. It means that everything was pretty much predicted and pre-planned. And if you look at the factories in those times, you didn't have humans close to the robots. So you would have robots in those big cages, and they were doing those automated tasks. And then now fast forward to basically the current time, you have robots that are used in very close proximity with humans. For example, the ones that are used in surgery. You have actually robots that are conducting surgeries on humans. However, the trick is that at the moment, these robots are completely controlled by the human. So we have the surgeon, who is the expert, and they are commanding the robots remotely, which is called telerobotics or telemanipulation, and they are completely controlling the movements of the robot. So this is where we have been, and this is where we are currently. But where we want to go from there is that we ideally would like to have robots who can work in unstructured environments in collaboration with humans and in close proximity with them. It means that we need to have robots which are, first of all, safe. They can perceive their environments and adapt to the changes that happen in that environment. They can predict what is going to happen next, and they can decide about what should they be doing with the current situation that they are encountering. And this is where the research is currently. So it means that we are working on AI techniques and machine learning techniques to be able to automate this human-robot interaction process. Now, in terms of the interfaces that are currently used, so in that surgical robotic scenario that I mentioned, currently the surgeon has basically some handheld devices. We can think of them such as some joysticks that they use to control the movements of the robot. The other interface that is currently used is the voice. You can, for example, have a robotic arm and you basically just command the robot, go up, down, left, right, and the robot will follow your order. There are also some studies going on with tracking some body movement. So for example, in the operating room, there are studies showing if we can track the head movement of the surgeon to command the robot. But all of these approaches that we currently have are actually like an additional burden on the human operator. Because in the case of surgery, for example, you have the surgeon who is actually conducting the surgery, and they don't want their mind to also think about how they should interact with the robot. So we are interested in more intuitive interfaces. And one of the futuristic ideas is to use non-invasive methods such as EEG. So currently, EEG is like having, for example, a cap of electrodes on your head, and then you can take the signals of the brain in a non-invasive manner and use them to command a robot. Currently, this can be used only for commanding in 2D. For example, you can move something to the left and right using your brain signals. But futuristically, this can be used for commanding more complex movements as well. The other interface that is now under research is to use augmented reality for commanding the robot. So augmented reality means that you can have a virtual model of your robot, which you can actually visualize in the 3D space. And then you can move that virtual robot, which can then be translated into the movement of the actual physical robot that you are interested in commanding. So I guess there is still a long way to go, especially in this human-robot interaction domain. And one other thing that I want to mention is the idea of shared control. It means that once you're doing a task, you have the robot alongside you, and you don't necessarily want the robot to do all the tasks for you. You want to make the most out of the robots and out of the skills of the expert. So you want them to be working jointly together, and each of them presenting their best. And this is something that arises a lot of questions about where is the right balance, and then if this is the case, who is going to be responsible for the outcome as well, which arises a lot of questions around the ethics and the related laws.
Yeah, absolutely. And I guess now moving and transitioning from that, it seems obvious that we're moving towards a future where we're going to be interacting with autonomous vehicles or machines very much in the real world that are powered by very strong algorithms. And the question is do you think that there's like an ethical question that it will be important for these machines or robots, and this is a question to all of you, where they all have to have some sort of perceptual understanding of what they're required to do? Like, should an autonomous vehicle understand its role in society as an autonomous vehicle in the same way that we understand to some extent what our role is as human beings, as agents, biological agents? So Dinh, I think I'll pass to you first. Do you think that we will build a form of AI that can perceive itself?
My view is this. First of all, right, I share a view with many experts in the field as well. The fact that when we think about AI, and we see a lot of fiction movies about robots versus human and so forth. First of all, my view is that this is not the AI and human and the robotics versus human. Okay, it is us plus the AI intelligence. So I endorse the views of AI, or even robotics technologies, augmented parts of our human capability. So in such a way, then there's not much about the contention between robotics versus AI versus us, or versus human, or robotics is going to take over the world. There's a glimpse possibility of that, possibly, if we let our imagination run wild. But let me take a quote from Alan Kay, which is the father of object-oriented programming. He said that the best way to predict the future is to invent it, right? So in that spirit, whatever moving forward in AI is in our hand, and then we can have a total control over that. Now, having said that, I do not underestimate some of the important things that AI can bring about. For example, the thing that for me personally is concern me is, for example, in civil surveillance at a massive scale, the privacies in the defense sector, for example, in automatic weapons, for example, just like if you think about the biological weapons, right? They are no less dangerous than atomic bombs. But people think about atomic bombs a lot, and then we also have regulations around those technology. So in a similar sense, I think that definitely AI should be regulated to that level. But I would concur on that AI ethics, and it need to be putting forward. And now the thing is, we should keep in mind the fact that there's a bit of catch-ups going on here, right? So on one hand, the technologies keep growing very fast. On the other hand, I think these questions is not simply the questions of the AI experts anymore. It's a question that go beyond that, and it involves everyone.
We're going to move to some questions from the audience very soon. But Jay, I was just wondering what you thought in regards to that question. Do you think that in the future, once we sort of have level 5 autonomy in vehicles, if you think that we'll get there or not, do you think it's important that the AI that controls these vehicles has some understanding of its role within society?
I personally don't think so. I think it's a very narrow task that you can teach a computer how to drive, how to get from point A to point B without wondering about its the great existential questions that plague us humans. Regarding you made a mention of level 5. So for the sake of some of the audience who might not know what this is. So the Society of Automotive Engineers in the US has categorized autonomous vehicles into different levels, going from level 1 to level 5, where level 5 is where an autonomous vehicle can operate anywhere in the world, requiring absolutely no human supervision. And then the levels below that are various sort of degradations of that. So for example, level 4 is one level under that, where an autonomous vehicle does not need any supervision from a human, but can only operate within a particular geographic geofenced area. Level 3 then is that the AV can operate in a geofenced area, but maybe needs some sort of human, the ability for the human driver to take over within about a few minutes of the AI asking for it to be taken over. Level 2 is driver assist, where the human being has to pay attention all the time. And I see one of the questions in the chats about somebody having one of these driver assist systems where the thing could park itself in a car park, and they had an accident because the human driver was not was doing something unusual, and the AI was not able to react in time. So this is what we would call the level 2 autonomous system, the driver assist system. The self-parking system is certainly a level 2 system, where it's simply a driver assist technology. And one of the things that you will notice in the fine print is that you have to be paying attention all the time. If the self-driving technology does something, the driver assist technology, it's not self-driving technology. If the driver assist technology does something, get into an accident, it is your fault. It is not the fault of the driver versus technology. So those are the two broad answers to your question. I don't think that the car needs to be self-aware to be able to drive, and two, I think that so we are still a ways away from level 5, but level 4 we should that is driving in certain geographical areas, we should be able to achieve in the next 5 to 10 years, if not earlier than that.
Well, when it comes to human beings reading the fine print, that doesn't give me a whole lot of hope that they're going to read that. But Ella, just to you, do you think there'll be an equivalent when it comes to robotic surgery in the sort of same categorization as autonomous vehicles? Do you think we get to a point where we have robots that can perform an entire surgery? And is there the philosophical, ethical question of whether the AI that's powering those robots needs to have some sort of self-awareness as to the importance of the task that it's doing? Or is it the similar thing? It's, removing organ A and replacing it with organ B in the same way that a hard drive is taking humans from point A to point B.
Yeah, so I think it's if we think really widely and have our imagination fly, it can happen at some point, like in a couple of decades, to have robots that can actually conduct some at least simple and straightforward surgeries, such as, for example, appendectomy, on their own without any human supervision. But I think that we are far away from that point at this point in time. The current state of the art is that, as I mentioned, we have the robots completely controlled by the humans, and then the research is looking into automating certain repetitive type of tasks, such as, for example, suturing, which means that you are making the stitches over and over. For example, if you need 5 stitches in a certain operation, research is looking into automating only that stitching part. So the common feature among the tasks that we are now looking at as researchers are the tasks that are structured and repetitive and easy to be identified. However, in a surgical task, the trick is that every human being is different. The internal organs, based on their gender, age, health conditions, is going to be different from the others. And that's what makes having a machine doing everything very difficult. So I think maybe in the autonomous vehicles area, things are more structured because we have the roads that are made by humans, and we have the cars that are the same. But in surgical domain, the I guess factors and the variables are more, and it's a more complicated domain to have automation. But I certainly think that we are quite close in having a certain level of automation for simple tasks, but having a full robot doing a complete surgery is still far away.
Absolutely fantastic. I think a consensus that I'm drawing from all of you is that much of the, let's say, hype that's existed within popular media, that's probably pushed forward by characters in the field like Elon Musk, who I think a lot of AI researchers tend to have pretty strong disagreements with at times, is that human beings in the near future, at least, maybe within our lifetimes, are going to continue to reign supreme with our meat machine brains. But the note that you've all touched on is that we are going to see a great optimization across all areas of life. And so I think, Aldeida, I'll switch to you. What do you think the impact of this optimization is going to be on our sort of more traditional jobs that we've come to train for? Is this a case where technology is freeing us up to do more creative things, or how do you sort of look at that?
Definitely. Can I briefly touch on the previous one? Because it's an interesting one and I agree with everyone. And when it comes to automation of software development as well, is exactly what Ilahi said. It's the same thing. If we have repeatable, simple tasks, they can be done with AI. But software, every piece of software will be different, and there will be a different context. So there will always be a need for a human being to look at that and to add the additional pieces. One example that our community was very excited about is Copilot, which is a GitHub plugin. It's an AI programmer assistant. So while you are programming, it suggests pieces of code. This is a piece of research that has been happening in the last 10 years in the software engineering community, but this is the first instance where it's in the real world and everybody's excited, similar to what happened with AlphaGo, when first it was demonstrated that it can beat the best game players in the field. And also, again, on your previous question, I'm sorry, but it's such an interesting question. The question is assuming that we have a self-determining AI. And the question that I think as a follow-up one, do we want that? And why do we need a self-determining AI? I think we can achieve it, but to do that, we would need to burn out all the forest in our Earth. And because training AI is such a computationally expensive task. Do we want to do that? Do we want to burn out our Earth to develop an AI that is so powerful? And for what? Why do we need that? When it comes to jobs of the future, and is there space for us? AI, can AI do everything? I don't think so. And again, relates to what Elahi was saying. AI is able to do things that are repeatable, that it can learn and then it can apply in a similar way. But the world is complex, humans are complex, and in particular when it comes to software development, again, since it's my field, I don't think we will come at a stage where code development will completely be automated. I don't think that is possible. There was a question in the chat. I am a software engineer. Should I become an AI person? Do we need software engineering? I think we need software engineering even more now because we need to build these systems and we don't have enough expertise. There's many articles out there, showing the increasing demand in this area in software engineering. So this will be a very exciting area to work on. We need people to build the system. So I think definitely that's an exciting space to be.
Look, we're only a couple of minutes away from finishing, team. And I think I might quickly throw one last question to Dinh, which is, when you look at these like deep learning neural networks, it becomes very difficult to find out how they're making those decisions. They almost operate like a black box. Perhaps you could touch on that from an ethical point of view. Is it important for us to eventually understand how these algorithms are making decisions, or is it only important that they end up making the right decisions?
Before I go into that question, Liam, I just want to touch upon the automation topic that Aldeida and Ali was talking about. I just want to raise another aspect of that automation process in terms of, I think it is important to recognize that the implication of that automation, right? So if you take an automation of someone in the factory, so that if you put a box on it and it wrong and then it drop, it's not so as critical as you do a surgery and then it go wrong, right? So then I think that's the level of automation, and the consequence of this automation is also dictates the way that we can adopt automations. So having said that, I think that I personally believe that there will be massive automations coming up in some of those tasks where the automation, if something's go wrong, it's not so critical, right? And I think that's on, will free us in many ways to focus on other meaningful jobs. Now, back to your question in terms of the black box and the decision part, this is also related to the job question, actually, because I believe that after you make a decision, then after you make a prediction, you have to act upon your prediction, right? So which means that you need a decision-making skill, and this is where the AI is still very far from being able to make sensible decisions in an optimal way. So now, when you talk about this decision, then more or less it's still on predictions. So what it means by black box? So I think one thing that most of us might not know, and maybe we obsess with black box, but in fact, not all of the AI algorithms are black box, right? So if you go back to the earliest AI research in machine learning, think about rule-based or you think about decision tree, which actually invented by an Australian professor, Ross Quinlan, in around 1950 and things like that. So these are the algorithms that can perfectly explain to you the reasons why it makes these predictions, right? So I think the black box actually it come around when in the rise of the deep learning in 2012, maybe when deep learning's algorithm beat the ImageNet competition, and then multiple panelists here already mentions about deep neural networks. So basically, it's just multiple layers of connected. What I call is computational unit, and people prefer it to like neurons. So it sounds like similar to the brain. And then each of these nodes actually is attached with a weight and activation function. So, so the learning process is all about tuning this weight so that it matches the ground truth, right? So for example, if you take a dog and the cat image classification problem, and let's say cat is 1 and dog is 0. So basically, if you got an image of a cat, you try to tune this weight so that its output is close to 1. Right, and then we do this by what they call is backpropagation algorithms invented about around 1986. Now, why do we call this thing black box? Because once this box is network is built, you do prediction by input an image, and it gives you 0 or 1, which is whether a cat or a dog. So now all you can see is this weight and the signals, right? Typically, we do not know exactly which patterns or which clues pixels contributed to this decision. So I mean, in many applications, like you playing game or you playing in the chess and things like that, these kinds of decisions are not so critical. So this shouldn't be a problem in my view, right? And many problems like that, we don't really care about explainability. You don't really need to care about that much. And then what I would like to say is there's a vast numbers of applications like that you don't require strict regulations or strict requirements on understanding why you make that decision, as long as you make this decision really, really well and really accurately. But I think I do aware of the fact that there's a concerns arising, for example, in the domain of medical, for example, or even in self-driving car, right? So these are important when it comes to the law and when it conforms with the law, and then when it's conformed to social agreements on how we operate as a society. So, for example, how do you come to the insurance and explain a decision, for example, and for this case of application, this domain of application, I certainly agree that. Being able to explain our decisions is important. Now, I once again, I would say that this is more than just the technology itself. This conversation should not be just people who are doing mathematics or engineering anymore. It is the conversation for all of us. But on the technology side, though, I would say that we have a bright side to think about it. Number one, as I said before, not all of the machine learning or AI algorithms are not explained, right? Some of them are really good at that. And if you don't need to do deep learning, don't use deep learning, right? Because it's also, suck up a lot of data and trees and so forth. If you really need to use deep learning technology, then this is a very active research topic, and there's several ways to tackle this at the moment, and there's huge progress is making along these directions as well. For example, you could look at the saliency activation maps to determine which pixels will activate when you make the decision, or you can build an entire new class of model that might perform as good as the deep learning model, but at the same time can be explained.
Fantastic. So I just being cognizant of everyone's time here within this webinar, we'll just quickly shoot to the Q&A and we'll try and answer these questions as quickly as possible. But first up is how students and graduates can get involved in this field without professional experience. And that has come from Julio. Jay, you can take that away.
Yeah, so I can give you the example of my own professional life. And so I finished my PhD around circa 2010 when deep learning was not a thing. Like you wouldn't do deep learning back then. So whilst working at a startup after my PhD, and I wanted to explore the field, which was then starting to gain currency. And I enrolled in what was then the very first MOOC, the massively open online course from Andrew Ng, who's a legend in the field. And so someone who's looking to sort of enroll, sort of get into the field today could do the same. So Andrew Ng founded Coursera, and today he has lots of courses on machine learning in Coursera that they can enroll in and start dabbling in this. But even apart from that, the best way to get into the field is to tinker. Download the neural nets, download the data sets from PyTorch or TensorFlow, pick one, doesn't matter, pick PyTorch, pick TensorFlow, download the tutorials and just start training and try to get a sort of a good feel for what is required for training these algorithms.
And Ella, what would you recommend to students or graduates who want to get involved but don't have any professional experience?
So I think it's following on what Jay was mentioning. There are now vast resources, online resources that can be used. Like there are like online courses, for example, in Coursera that people can follow. So I think that although like having a university degree can be helpful, but it's not the only way to approach this. And like, so I guess go with that and then try to solve some example problems for yourself. So define a mini project for yourself which interests you, and then try to tackle that mini project, and it will give you the experience and the knowledge required.
Cool, fantastic. And then maybe from each of you, do you guys have one book that you would recommend to a student as reading material in these domains? And since you're on screen, Ella, you may as well go first.
So I would recommend a book in robotics, which is basically like the encyclopedia for robotics. And its name is Robotics, and it's published, if I'm not mistaken, in 2018. It covers all the areas of robotics, including machine learning, but not limited to that.
Fantastic. And Aldeida, do you have a book that you would recommend?
Yes, there are many interesting books, hard to choose, but one that I think is very interesting is Human Compatible by Stuart Russell, which touches on some of the issues we've discussed in this panel.
Yes, correct. I know he's been very vocal about weapons that are powered by AI. Dinh, do you have a book that you would recommend to students or graduates?
Yeah, so I could be biased to my teachings. So I cannot recommend the textbook that I use for my course. So that is the Hands-on Machine Learning with Scikit-learn and TensorFlow. I think this is a fantastic book for people who would like to get on deep learning. If you like to be a bit more advanced, then look at the deep learning book from Ian Goodfellow. And in terms of, I just want to pick up from Ray as well. So in terms of how to get into this field, I would say that also be careful about what you can do in the short term, in the long term. If you download a course and you GitHub something, you pull a GitHub course and a GitHub repository and you can rerun it. It looks nice, and then it gives you some hand-on experience right away. But if you would like to progress further in your career, then I would recommend that have a solid foundations of why this algorithm works, why it failed, being able to develop the new algorithm and understand, for example, basic concept of bias or variance in machine learning, understand where it can be used, when it cannot be used, are very important. The other thing I would recommend is try to get on an internship at some place. Okay, have a focus the projects as well is always a great way for you to get started. Get an internship at some of the AI company or a company that requires skill in data science and AI is also a great way to start in your career.
Absolutely fantastic. And then I think lastly, we're going to end up on this last question, and this is directed to you, Jay, which is, what is the difficulty in resolving the trolley problems of autonomous vehicles, such as the decisions between saving the driver versus the pedestrians? And is that something that your team thinks about or works on? And that's come from Nathan.
Yeah, this is a difficult question that I don't have an answer to or a straightforward answer to. So the trolley problem is a problem where you can imagine a trolley, which is like a tram in Australian parlance, right? But in the US, trams are called trolleys. So you have the two tracks of the tram or trolley, and then you can only go down one of these you're currently on one path, and then you're splitting into these two different paths. And if you go down one path, you're going to run over a child. If you go down another path, you'll kill yourself. So then, or something like this. I mean, this is the rough problem. So which one do you choose? So this is a very difficult problem for a robot to answer. Maybe as an autonomous vehicle sort of specialist, I would say you don't have to choose. You apply the brakes and come to a stop as soon as possible and prevent yourself from having to make either decision. But yeah, I mean, there are probabilistic weights assigned to different detections and where these detections are going to be in future, in the immediate future, from 1 second out to about 5 to 8 seconds out. And then you have to plan your path so that it does not intersect. You have to plan your path safely around the projected trajectories of other agents around you. And so this is the fundamental problem of sort of perception in autonomous vehicles. And so you then plan a trajectory that is most optimal and most safe, that does not involve intersection with any of these trajectories. So yeah, we don't really think about the trolley problem all that much from a day-to-day perspective in the field.
Cool.
But it is a legitimate sort of reasoning problem that you can pose overall. Like, what are the ethical sort of dimensions of making one decision over the other?
Fantastic. Look, we're going to conclude here. We're running a little bit over time, but I would just like to thank all of the panelists who have joined us here today. We've had Jay, Ella, Aldeida, and Dinh. Jay joining us, obviously, from the United States. All of you guys have been absolutely fantastic, extraordinarily interesting. There were some questions there that unfortunately we didn't get a chance to get to, but I believe that you'll be able to find all of these people with a quick Google search and their emails either through the Monash University website. So if you had any other questions that you really wanted to follow up and get some answers to, I would suggest doing that. It never hurts to reach out to people cold. And also, there will be a survey for this event, a post-event survey that will be emailed to all of the participants today. If you could let us know what you think, that would be absolutely fantastic. And don't forget to follow Monash Infotech on Facebook and Twitter. And that concludes our event for today. Thank you very much.
Thank you.
Goodbye.
Thank you. Bye.